Okay guys, I just had a peck at it. It's working as expected. It's not very aggressive because it doesn't have a lot of clearance. It's just a shaving tool. It's taking a little bit at a time. I'm doing these because I had another look at the bridge deck yesterday, and we have hundreds and hundreds of Phillips head decking screws to take up out of the timber as we paint underneath it and replace the rugged bits of wood. And quite often we're going to have to drill the heads off screws, I think. Okay, we'll give this a bit more of a try and see what it does. Well, to be honest with you, for a no pilot 3/8 drill, it's not doing too bad. As the material gets hot enough, it drills into it. It won't be that easy to use by hand. Well, that's it. Mission accomplished. I'm quite happy with that. Takes a bit to get started, and I think the drill is working its way through quite a bit on thermal failure. And yeah, there's one hell of a burr underneath. The big piece just broke off. Let's have a look at how bad that is. Yeah. So there's a reasonable sized burr on the back to be expected. The hole itself, nice and round. Yeah, I'm happy. It's done a pretty good job. Originally, these sorts of drills were armour piercing drills or rail drilling drills. And worse luck, this bit of high-speed steel is only M2, it's not M42. So I don't expect it to perform like a good piece of cobalt steel. I have plenty of that cobalt steel in squares, but there weren't too many manufacturers of it in rounds, and I find that quite surprising because it would be used quite a bit for boring tools, line boring, etc. Let's have another go. It's just like expected. It takes a fair bit to get us started, but the progress is constant. You know, once that point's worried its way through, it just starts to drill a hole. There we go, starting to chew a bit of material now. And yes, I am putting moderate pressure on it, but it's a 3/8 drill with no pilot, so you've got to expect some pressure required. Producing a bit of heat. And through we go. When I've got the tiller cutter grinder set up again, I might try to thin the point. Okay, let's move on to a different job. G'day guys, back again for episode 2. I've got the motor set up in the vertical mill to drill and tap 4 holes to put mounting studs so it can go up under the gearbox. And disappointment. It took me hours to figure this bloody setup out, and I'll show you what it's like. And see if I can zoom you in a little bit. Okay, this is the front mounting for the motor. It's drilled and tapped 3/8 UNC, and I'd need quarter British Standard fine on a slightly smaller PCD. So I figured best way is just to drill this front flange. It's got to be a fairly solid flange, being the front motor mount. And it appears now I've got to pull the plate off and have a look inside, because bugger me, I only got down 3mm deep and there's a hole straight through into the guts of the casting. And I can't muck about too much, because if I do, I'll finish up with a whole lot of aluminium swarf in there as well. I would say that to be mean on material, they've wasted the back so that there is almost anything around there. Oh, and ah, but I might take it apart. Probably the best bet. Well, guys, welcome back again. And here's me thinking I'd get a good deal. Back into this motor, I went to transfer the holes over to the mount side of the flange. I'll zoom you down a little bit and in. And I can't believe what I got. Like, I'm aware that you've got to make savings somewhere, but I think this is just taking it a little bit too far. Okay, I pitched out the circle for the quarter BSF mounting studs that I was going to screw in here. I assumed that this would be reasonably thick. And on drilling the first hole, I looked at it and I thought, what? Can't believe that. I think it's 2.4mm thick. And I thought, can't be. I've missed something inside. So, turn it over. And that's what the inside of the flange looks like. Thickness here is about 4mm. 2.4 there. It's reasonably thick in the castings where the surface mount bolts go into and where the tie bolts go through, but there's not even enough material inside these lugs for me to drill the PCD. And I'm thinking, bloody hell, what do I do? Oh, and also thickness of the casing, 2.1mm, and there's a bit of a bourbon there that I'm measuring as well. I'm thinking, shit, there's not much going into this motor. And the rear flange of the casing is exactly the same. So just absolute light material. I'd hate to see this. It's a 1 horsepower motor. I'd hate to see it working on a cement mixer or on a saw bench or something like that, especially where the motor cantilevered off the front flange and just all the weight hanging on that and a bit of vibration. Yeah. Another thing that I've come across is there's balance weights on some of these spigots in the casting for the rotor, but a lot of them, the spigot has been staked back, but not enough to fix the washer. So the thing's going to be rattling the whole time that it's working, giving out a methodical 50 hertz buzz. Well, that's the way it is. I will say, electrically, to me, and not being an electrician, it looks well wound, well made. I can't see anything that has stopped me from using it except these flanges. So I'm going to source a piece of material and do a series on building a new flange for the front of it. But it's just a bugger. I thought I was only that far off bolting it up. Whoop, that far, which isn't much. But no, it's not like that at all. Anyway, that's what we're up to, trying to make up for me buying a piece of cheap shite. Okay, I'll see if I can find something on putting a split point on a spade drill or something like that. I have to call it quits. I'm getting ready for track and tent, so I've got to get the cameras charged up and the cards cleaned out. Okay, bye for now. G'day guys. Well, we've swapped projects back onto the Clarkson tool and cutter grinder. I'm now going to split the point of the drill. I had a look at a commercially made drill, and the cutting edge is about 45 degrees rotated clockwise from horizontal. In other words, you're putting the notch in about 45 degrees to that cutting edge. Now I've also tilted the workhead back at 10 degrees. That's what they've done in the shop, and it also means you put a very, very short notch in the end of the drill and achieve the relief that you want. Okay, let's pick the grinder up and see what we get. All that we're trying to do is reduce the length of the chisel edge and give it a little bit less rate. Just touching off there. And that's very close to where we want it. This is kind of a little bit uneven. We'll give it a few more hits and see what it's like. Turn off your bastard. And I might bring it back a little further that way. No, you read it the other way. Not that left, the other left. That's your more. Okay, now they didn't come out dead even. Obviously my drill is not centered perfectly. But I'll swing that around and we can see how close it got to where we want to be. Now I might take a little bit more off that. I'll bring it back when I finish finding out. I think we're a little bit closer now. There we are. There we are, guys. We've got a little bit of a notch. I can see now, unlike those commercially produced, which of course are perfect, this notch is a fair bit longer. I don't think it's deep enough to weaken the end of the drill. I should have tilted the workhead back a little bit further, or had the drill approaching the wheel a little bit higher. I was passing underneath the wheel. I could have approached it higher to get a much shallower or a much shorter grind, but once again, no table stop on this machine. Okay fellas, next week, after it's all died down and track and tent is over, we'll put that up in the mill and see if we can make a decent hole with it. It's a bit of new science to me. Something, as I said, I'm doing for a club project. We'll see if we can make it work. Bye for now. If you haven't already, please like and subscribe.